Okay, here we have a question about ideal gases. Feel free to have a go, and then when you're ready to see the explanation of the answer, press play. Okay, so I think it's important to have a quick look at the wording of the question. We've got the piston being, which is holding our gas, and then we're going to compress it rapidly. We're told that the average speed of the gas molecules increases, and we're being asked to identify why, and I think that's quite a nice question for us to think about. Okay, we're looking at the answers here. There's a few things which are true. For example, they have a smaller volume, that's true. They are making more collisions every second with each other. These are all valid statements. However, they're not necessarily explanations of why the things travel more quickly. For this, what I think it's worth doing is looking at our equations that we have. And I think, for me, the telling one is this. Our internal energy is equal to the sum of the potential, in this case 0, and kinetic energies of the particles in the system. And so we have this equation, U is equal to 3 over 2 n kBT, where n is the number of molecules, kB is the Boltzmann constant, and T is the temperature. Now, what we can see here is that if we increase the temperature, we're increasing the internal energy, and therefore increasing that speed that each of these particles has. So if we've got an average speed increasing, then we must have received some energy from somewhere. That internal energy must go up, and the question is where that has come from. And I think this is something which students often take for granted. That energy has come from the piston itself. By compressing the gas, the piston is doing work on the gas. And if we look from a sort of macroscopic point of view, if we do work on the gas, if we're doing work on it, then we are increasing its energy. By increasing its energy, we're increasing its temperature, and the result of that is an increase in speed. And so therefore, our answer here is that we've received energy from the piston. In what form? Not through heating, not through a flow of heat energy, however, through work done by the piston on the gas. And this is a really nice example of the link between work and the internal energy of a substance.